Okay, so start on your rating notes where it said, where you have the E. You have E, and you wrote end behavior, right? So that little piece. And if you look on the inside, we had horizontal asymptote or a slant asymptote. It has to do with the end behavior. You know, if we were top heavy, bottom heavy, tied, and the only way you have a slant asymptote is if the numerator is higher than 1 degree of the denominator. Okay, it can only be higher by 1. So on the outside, so there's no room inside your rating notes. So like this is the margin of your ISN, like right here, right? You just write what we're going to do right here, right? And somewhere where you're like pointing to the end behavior. And here's what we're going to write. And I'm going to write it underneath here, but you know, you just make it fit next to end behavior. At least be pointing to it, whatever happens. If degree of numerator is more than 1 higher than denominator. You understand what I mean by that, right? Okay, so if it's like x cubed in the numerator and just x in the denominator, right? Then it has polynomial and behavior. Okay, polynomial and behavior. What I mean by that is this. If it is higher by even number, then it acts like this or this, depending whether or not it's positive or negative, right? And if it's higher by an odd number, then it looks like this or this, depending on whether it's positive or negative. So just like it was for polynomials. I knew I was leaving that off on Friday because I knew there wasn't room, and I was trying to find a shorter way to say all that, and I couldn't come up with one. So we'll just put that out to the side like that. But the end behavior is going to be very important in you knowing how to graph these, because some of them are kind of interesting, right? Everybody good with all that? Then you want to keep your rating notes handy because we are going to look at some of these examples. So you have 2 sets of notes that look pretty close to being the same as each other. We're going to start with the first one. So get number 1. And I think unless sometimes I do things and then it renumbers it because it thinks it's smarter than me, which it probably is. I'm pretty sure one of the notes should start with 1 and the second one should start with 4. Is that actually happening? Yes? Okay. And it says part 1 and part 2 at the top. Is everybody done writing all this? Yes. Oh, thank you. Yes, we wrote something on 77. I didn't say that to everybody. And then, yeah, somebody pointed that out to me and I fixed it. I'm sorry. It's 78 and 79. Thank you. All right, so this is actually going on 78. So we're looking for all these things. I have Rady written out to the side because, yes, right now there are blanks for what you need, but there isn't always necessarily going to be blanks. So you want to make sure that you think through all of this, plus more if possible. On the first ones, or I'm sorry, at the beginning up here, I want it 100% factored out every time it can be. Here, clearly we can't factor anything out, but does this one have any holes? No. Okay, so we have none there. Do we have any roots? Yes, and I wrote it as roots instead of x-intercepts, so that'll be easier to write. What is it? 3. Is it possible not to have any roots at all? Yeah, totally is. Do we have any vertical asymptotes? Yes, -2. That's when you set the denominator equals 0, so we got x equals -2. And then tangency and togetherness. So what are we looking for to figure out if we have that? It's do any factors of r or a have an even exponent? So basically, and think about it this way, this is t squared. You're looking for the numerator. Do you have any factors that are, double factors or quadruple factors, that type of thing? Do I have that? Got a square in the numerator or denominator of the same one? No. So there's no tangency or togetherness. So that tells me something. There not being any is important. That tells me something. That tells me that they've got to go opposite directions whenever we come to an asymptote. And then your end behavior, do we have a horizontal asymptote? Yes, because they're tied. So what is it? 1? Yes, we're good? So y equals 1. Do I have a slant asymptote? No. So none there. Do we have a y-intercept? Yeah, -3/2. It's pretty easy to find. So that's 0, -3/2. Then we're going to do our little number line. And on your number line, you put whatever roots you have and whatever vertical asymptotes you have. So I have a vertical asymptote at -2. I have a root at 3. And I can no longer see my function, but you can see yours. You can see mine on my paper. So if I plug in a -3, and the numerator, is it negative or positive? Negative. And then -3 plus 2 in the denominator would still be negative. So negative over negative gives me positive. What's an easy number between -2 and 3 to pick? 0. Okay, so that means I would get a negative and then a what? Positive, which makes this negative. And then I would get, if I plugged in like a 4, I'd get positive over positive, which is positive. So this tells me something. If I think about the number line as being my x-axis, then all the way up from -infinity to -2, it's positive. It's above the x-axis. From -2 to 3, it's below the x-axis. From 3 to infinity, it's above the x-axis. Everybody good? You have colored pencils that are erasable, so there is some forgiveness there. In your box, if you want to do your asymptotes different colors, that might be helpful to you. There's also sharpeners in the back, and if these are all dull. But let's see, let's do our, so my vertical asymptote, I'll have to look at my paper, is at -2, right? So I'm going to draw that in. Make sure you're actually drawing them in. There is, on one of the homeworks that I graded, some of you used the asymptotes, like they were, you used them, but they weren't drawn in, which tells me you're probably just looking at a calculator when you did it. So make sure you actually know how to do this by hand. And then my horizontal asymptote is y equals 1. You wouldn't even necessarily need to do them like in different colors. I am, so I can keep up with what's what, but doing them in color may be helpful. Maybe if mine were wider, they'd be better to see. It's a little bit better. Okay. So here's what I know. I know from -infinity to -2, it's positive. So you think that means it's going to be probably most likely above my horizontal asymptote, you think? Yeah? All right, so we have some key points that we need to plot. We're going to plot our root, which is at 3. We are going to plot our y-intercept, which is at 0, -3/2. It's about right there. We don't have any holes. If you have a hole, you want to go ahead and make sure you draw that in. And then, so for this part of the graph, from going from -2 to infinity, I know where I'm supposed to be negative, and I know where I'm supposed to be positive. So were you pretty confident we could draw that part of the graph, you think, with just those 2 points? Since this is the asymptote, it's going to have to come up here, go through those, and then get really close to that one, like so. Does that mean that there's nothing happening over here? No, because we know there's something happening, right? So we need to pick a couple of key points. So just a couple quick for x and y. Let's see what might be good. Maybe a -3, see what's going on there. I'm going to pick a -3. when I pick that, so that's going to give me negative 3 minus 3 over negative 3 plus 2. So it's going to be negative 6 over negative 1. What's that? 6. So that's a pretty decent point. Worked out nicely. So negative 3, 1, 2, 3, 4, 5, 6. And I'm not going to make you plot 1,000 points for each one of these because it's not always necessary, but there's a lot of things that could happen here. This could come really close down like this. This could curve and be way out here, like we're not really sure. So if I pick another one, if I pick maybe negative 6, that was the other one that I just randomly picked because I wanted something a little farther out to kind of know what was happening here. So at negative 6, you give me negative 6 minus 3 over negative 6 plus 2. So that's negative 9 over a negative 4, which is just 9/4. So what? That's like 2 1/4. That's not too bad to plot, right? So if I go to negative 6, 2, 4, 6, and up to 2 1/4, somewhere right about there, that kind of gives me an idea of the spread. But there's nothing special about those 2 points. Those were just kind of where I thought it might give me a good idea of the shape. And then there's my graph. Everybody okay on that one? Any questions? All right. Now on this next one, I'm going to give you a couple of minutes to see how far you can get on some of this stuff. Okay. So get it all filled out, try and get it. I filled in the stuff. I kind of walked around and it looked like most of y'all had gotten at least this far and gotten all this okay. Anybody have any questions about this? I didn't miss anything. Okay. So does it have a slant asymptote? So how am I going to figure out what that is? Synthetic division. Could I use long division? Yes. Is synthetic division a little easier? Yes, but that's a matter of opinion. So if I use the 1, right? Now, this is x squared minus 9, which means I have to use a 1, a 0, and a negative 9. You have to have a placeholder. Okay, so 1, 1, 1, and then the rest doesn't really matter. So that means I get y equals x plus 1. Right? Everybody okay with that? All right, what's your y-intercept? 0, 9. Okay. And then in our little number line here, we have to put negative 3, 1, and 3 on here. So from negative infinity to negative 3, is it positive or negative? Negative. And then from negative 3 to 1, what is it? Positive. Then negative, then positive. We all agree with that? Okay, that's what we should be able to get. Okay, good deal. So then let's graph it. Let's start by graphing the vertical asymptote. So there's my vertical asymptote, and then my horizontal asymptote. No, I don't have a horizontal asymptote. It was a slant asymptote. Y equals x plus 1. So here's this, and then the slope is 1. So when the slope is 1, even if you don't have a ruler and you're doing a dotted line, you should be able to go diagonally right through your little squares there. But a straight edge is always good to have on hand. Right, so there's my asymptotes. I'm just doing them thicker so you can actually see them better. So I plot my important points. I have a positive and a negative 3. So 1, 2, 3. 1, 2, 3. And then my y-intercept is at 0, 9 here. So I know from negative infinity to negative 3, I'm negative, so I'm coming up this way. And then when I hit negative 3, it becomes positive, so that makes sense. And then from 1 to 3, I'm negative, then it becomes positive, so I think I can get the shape in here pretty good. Something like this. Okay, everybody okay with that? If you want to throw in a couple extra points, you can, because on the right-hand side especially, we may not be 100% exact, but it's okay. We're just trying to get the general idea here. We good? All right, any questions? All right, so now I actually want you to jump to number 6. I want you to jump to number 6. And I want you to go ahead and I'm going to pass out the homework because it's in 3 pages because they're big graphs while you fill in the stuff for number 6. Okay? Alrighty, so do we have any holes here? No, so that's none. What are our roots? -4 and 1. And do we have any vertical asymptotes? Yes, where? X equals -2. Good. Do we have any tangency or togetherness? Yes. Which one? Tangency or togetherness? Togetherness is the denominator. So we are together. You know what I mean? Where? At the asymptote, right? X equals -2. That means they go in the same direction, whichever it may be once we get there. Okay, that's together. That's what that says. Do we have any horizontal asymptotes? Y equals what? 3? Yes, 3. Sorry, I'm just trying to, I don't have the right one written down in front of me. Y equals 3, because that changed at the last minute. Do we have any slant asymptotes? No. Do I have a y-intercept? Yes. What is it? 0, -3. Okay. Everybody good? Yes. All right. So let's look at our number line. On our number line, we have to put -4, -2, and 1. So if I look at a -5, so if I plug in a -5, in that first one, it's going to be negative, right? In the second one, it's going to be negative. And then in the denominator, it's going to be positive because it's squared no matter what. So we are positive here. Everybody good with that? I plug in a -3. So -3 times 3 and then -3, that's still going to be negative. Then when I plug it into x plus 4, what happens? Negative or positive? Positive and then positive. So overall it is negative, right? Between -2 and 1, I can plug in 0. So that's going to give me negative, positive, positive, and that is negative. I can plug in 2, and that's going to give me positive all around. And there's my little chart of what's going on. Okay, everybody with me so far? Yes? All right, so let's graph our asymptotes. We have a vertical asymptote at -2. We have a horizontal asymptote at y equals 3. And let's plot our key points. So our key points are at -4, at 1, and then our y-intercept is at 0, -3. All right, so I want you to tell me about asymptotes. What is an asymptote? Anybody tell me? Like, I mean, we're drawing them, right? I can say draw the asymptote. You're like, all right, I can do that. But what is it in our function? Can you cross it? Okay. That's why in the little flap inside of your radii, it's on end behavior, right? It doesn't talk about whether or not you can cross anything because you can cross an asymptote. It's about end behavior. So it can cross it. It can actually cross it a couple of times, but at the end, it just approaches it. So on this one in particular, now, in this case, for this problem, it's kind of a wacky one, and that's why we're working it, but you wouldn't necessarily know that it crosses it, because if you're going to just graph it from here, you're probably going to graph it and make this underneath y equals 3, right? That's probably what we would do, right, on both sides. But if that intercept, or if that asymptote was at y equals 0, and then you knew it was supposed to be positive on the left-hand side of it, it's going to seem weird. Like, it can't be positive because it can't cross the asymptote. But you can cross the asymptote. All right? And this one, in fact, does. You wouldn't necessarily know that going in, okay? And I know that. That's why we're working this one. But there's going to be a couple on your assignment where it does cross it. And it will be obvious that it has to, because it's going to be weird to you that you've got to, you know, you're supposed to be up here, and then you have a point down here, but you got to cross that asymptote. Just know it's about end behavior, okay, and what it's approaching. So I'm going to go ahead and tell you on the right-hand side, it doesn't. All right, so we're going to go ahead and draw in this right-hand side. Oh, goodness, maybe I can draw that better. Okay, that's still not great, but good enough. And I know that this is supposed to be negative up to here, and then it's going to go positive, but it would be nice if I knew where it intersected the asymptote. So how do you think I can figure out where it intersects the asymptote? Say that again. Plug in the asymptote, right? What is the asymptote? 3. So y equals 3, right? So if I make y equals 3, I can do 3 equals, what is it? I don't even have it written down here. 3 equals 3x minus 3 times x plus 4 over x plus 2 squared. Is that something you can solve? And it actually comes out pretty nicely, way better than you might think it does. So why don't you work on that? So you can get that one solved. Okay. So the bell's going to ring here in just a second. So here's what we're going to do. We're going to start here tomorrow. But one thing I wanted to make sure you knew before you walked out the door